GCE O Level Mathematics, Lecture 8, Ratio, Rate, and Speed. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. The learning objectives of this lesson are to understand the concepts of ratio, to state the relationship between ratio and fraction, to solve problems involving ratio, to understand the concepts of rate and average rate, to understand the concepts of uniform speed and average speed, and to solve problems involving speed. What is ratio? Ratio is used to compare two similar quantities. Given two similar quantities, A and B, the ratio of A to B can be defined as A to B, or A over B as a fraction, where B cannot be equals to 0. Ratio is always positive and has no unit. If A over B is less than 1, it means A is smaller than B. If A over B equals 1, it means A equals B. If A over B is greater than 1, it means A is greater than B. Let's look at this example. Given that there are 15 boys and 18 girls in the playground, find the ratio of A. The number of boys to the number of girls. B. The number of boys to the total number of children in the playground. Here is the solution. For A, the number of boys to the number of girls equals 15 to 18. We can simplify this ratio to be 5 to 6. For B, first we find the total of children, which is 15 plus 18, because there are 15 boys and 18 girls, and we get 33 children. Hence, the number of boys to total number of children equals 15 to 33. And we can simplify this ratio to be 5 to 11. Remember, always leave your answer in the simplest form. Or, we can use another method to find the answer for B. From A, boys have 5 parts, and girls have 6 parts. In total, there are 5 plus 6, which is 11 parts. Hence, the ratio of the boys to the total number of children equals 5 to 11. Let's try this similar example yourself. There are 36 oranges and 54 apples in the basket. Find the ratio of A. The number of oranges to the number of apples. B. The number of apples to the total number of fruits in the basket. You can pause the video and try to solve it yourself. Alright, here is the solution. For A, the number of oranges to the number of apples equals 36 to 54. And we can simplify the ratio to become 2 to 3. For B, first we find the total fruits, which is 36 plus 54, and we get 90 fruits. Hence, the number of apples to total number of fruits equals 54 to 90, and we can simplify it to be 3 to 5. Or, there is another method to get the answer for B. From A, oranges takes 2 parts, and apples take 3 parts. Hence, the total parts are 2 plus 3, which is 5. So, the ratio of the number of apples to the total fruits equals 3 to 5. Now, let's see another example here. Ali and Ben completed a race in 51 seconds and 1.5 minutes respectively. Find the ratio of Ali's time and Ben's time. Here is the solution. The ratio of Ali's time to Ben's time is 51 seconds to 1.5 minutes. However, we can't leave our answer in this form because both quantities have different unit. We have to standardize the unit. Hence, we have to change the minutes to seconds, and the answer becomes 51 seconds to 1.5 times 60 seconds, and we get 51 to 90. We can further simplify the ratio to be 17 to 30. Here's a note that you need to pay attention. The quantities in a ratio must be in the same unit. Units are not required to be written in ratio. Therefore, as you can see from the answer, we only have 17 to 30. We don't leave answer as 17 seconds to 30 seconds. Here is one example that you can try yourself. The height of a tree is 2 meters and the height of a potted plant is 40 centimeters. Find the ratio of the height of the tree and the height of the potted plant. You can pause the video and try to solve it yourself. Alright, here's the solution. The ratio of the height of the tree to the height of the potted plant equals 2 meters to 40 centimeters. And we have to standardize the unit, which becomes 200 centimeters to 40 centimeters. Next, we simplify the answer to become 5 to 1. From the ratio, we can make a conclusion that the tree is 5 times higher than the potted plant. Simplification of ratio. Ratio can be represented in fraction. Here's an example. The ratio of 1 to 2 can be written as 1 over 2. The ratio of 2 to 4 can be written as 2 over 4. The ratio of 3 to 6 can be written as 3 over 6, and so on. Notice that the ratio of 1 to 2 equals the ratio of 2 to 4 equals the ratio of 3 to 6. The ratio of 1 to 2 is the simplest form. In general, we can say that the ratio of A to B equals the ratio of MA to MB, where the quantities of A and B both are multiplied with the same number, which is M here. And we can say that the ratio of MA to MB is equivalent ratio of A to B. Similarly, the ratio of A to B equals the ratio of A over M to B over M, which means that both quantities of A and B are divided by the same number M here. And we can say that the ratio of A over M to the ratio of to B over M is equivalent ratio of A to B, where M is not equals 0. Let's look at this example. Simplify the following ratios. A. The ratio of 2 to 2 over 3. B. The ratio of 2 and 5 over 6 to 4 and 7 over 8. C. The ratio of 0.130 to 0.204. Here is the solution. For A, the ratio of 2 to 2 over 3, we can make these two quantities to have the same denominator, and it becomes 6 over 3 to 2 over 3. Since they have the same denominator, then we can just remove the denominator and it is equals the ratio of 6 to 2. Then we further simplify this ratio by dividing 2 for both quantities, we get 3 to 1. Another way we can simplify this ratio is by multiplying 3 for both quantities so that we can get rid of the fraction. So it becomes 2 times 3 to 2 over 3 times 3. And then we get 6 to 2. Then the remaining steps are the same. And eventually we get the answer as 3 to 1 in the simplest form. For B, we have fractions for both quantities, right? 2 and 5 over 6 to 4 and 7 over 8. Both are proper fraction. The first thing we need to do is we change them to improper fraction, which becomes 17 over 6 to 39 over 8. The LCM of 6 and 8 is 24. Hence, we can make them to have the common denominator of 24, and we get 68 over 24 to 117 over 24. So the ratio becomes 68 to 170. Or we can multiply both fractions with 24 to get rid of the denominator, and we get 68 to 117 as well. For C, the ratio of 0.130 to 0.204. For this example, we see that both quantities are decimals. So we can change them to fraction, which is 130 over 1000 to 204 to 1000. And the ratio becomes 130 to 204. Then we simplify both quantities by dividing 2. We get 65 to 102. Now you can try this simple example yourself. Simplify the following ratios. A. 3 to 3 over 5. B. The ratio of 1 and 3 over 4 to 3 and 1 over 3. C. The ratio of 0.42 to 0.51. You can pause the video and try to simplify the ratios yourself. Right, here's the solution. For A, the ratio of 3 to 3 over 5, we can multiply 5 for both quantities and we get 15 to 3. Then we can further simplify the ratio by dividing by 3 for both quantities and we get 5 to 1. For B, since both are proper fraction, we can change them into improper fraction, which is 7 over 4 to 10 over 3. The LCM of 4 and 3 is 12. Hence, we can multiply both quantities by 12 and we get 21 over 40. For C, since both quantities are decimal number, we can change them to fraction, which becomes 42 over 100 to 51 over 100. And the ratio becomes 42 to 51. We can further simplify this ratio by dividing both quantities by 3 and we get 14 to 17. Ratios of three quantities. A ratio can be used to represent more than two quantities. Here is an example. Let's say A equals 12, B equals 18, and C equals 24. Hence, the ratio of A to B to C equals 12 to 18 to 24. The HCF of 12, 18, and 24 is 6. Hence, we can divide all these three quantities by 6 and we get 2 to 3 to 4. Notice that a ratio involving three quantities cannot be written as a fraction. Let's look at this example. If the ratio of A to B equals 2 to 3 and the ratio of B to C equals 5 to 6, find the ratio of A to B to C. Here is the solution. Given that the ratio of A to B equals 2 to 3 and the ratio of B to C equals 5 to 6, we can see that the quantity B is the common quantity. However, the value of the quantity B for both ratios are different. Hence, we have to standardize the value of this quantity first before we can combine the quantities A to B to C. The LCM of 3 and 5 is 50. Hence, for the first ratio A to B, we multiply both quantities by 5, and we get the ratio of A to B equals 10 to 15. Similarly, for the second ratio, B to C, we can multiply both quantities by 3, and we get the ratio of B to C equals 15 to 18. And now, the value of B is the same for both ratio, which is 15. And we can combine all these quantities together in one ratio, which is the ratio of A to B to C equals 10 to 15 to 18. Now, you can try this similar example yourself. If the ratio of x to y equals 3 to 2 over 5 and the ratio of y to z equals 1 to 5 over 7, find the ratio of x to y to z. You can pause the video and try to find the answer yourself. Alright, here's the solution. Given the ratio of x to y equals 3 to 2 over 5 and the ratio of y to z equals 1 to 5 over 7. The very first thing we need to do is we have to simplify both ratios to the simplest form where the value for both quantities must be a whole number. Therefore, for the first ratio, we multiply both quantities by 5 and we get the ratio of x to y equals 15 to 2. For the second ratio, y to z, we can multiply both quantities by 7 and we get the ratio of y to z equals 7 to 5. Notice that y is the common quantity, but they have the same different value, which is 2 and 7. The LCM of 2 and 7 is 14. Hence, for the first ratio, we multiply both quantities by 7. And for the second ratio, we multiply both quantities by 2. So for the first ratio, x to y, it is equals to 105 to 14. For the second ratio, y to z, it is equals to 14 to 10. Now, the value of the y is the same, which is 14. Then we can combine these quantities to become one ratio, which is the ratio of x to y to z equals 105 to 14 to 10. Now, let's discuss some examples related to word problems involving ratios. Here is one example. Mango puree, coconut milk, and syrup are mixed in the ratio of 5 to 4 to 3 by volume to make a cup of mango dessert. If the volume of the mango dessert is 600 ml, find the volume of each ingredient used. Here is a solution. The fraction of mango puree equals 5 over 5 plus 3, 5 plus 4 plus 3, which is 5 over 12. To find the volume of mango puree, it is equals to 5 by 12 times 600 because this mango dessert is 600 ml, and we get 250 ml. Similarly, to find the volume of coconut milk, it is equals to 4/12 times 600, as the coconut milk takes 4 parts, and we get 200 ml. To get the volume of syrup, just take the total 600 ml minus 250 ml from the mango puree and minus 200 ml from the coconut milk, and we get 150 ml. Now, let's try this example yourself. The diagram shows the suggested portion of food in our meals by Health Promotion Board. A. Express the ratio of fruits and vegetables, whole grains, and protein in the simplest form. B. If an average person eats 500 grams of food per meal, find the mass of each type of food consumed by an average person. You can pause the video and try to find the answer yourself. Alright, here's the solution. For A, the ratio of fruits and vegetables to whole grains to protein equals half to 1/4 to 1/4. So the LCM of 2 and 4 is 4. Hence, we can multiply by 4 for all these three quantities, and we get 2 to 1 to 1. For B, let's find the mass for fruits and vegetables first. So it is equals 2/2 plus 2 plus 1 times 500, and we get 200 grams. For whole grains, it is equals to protein, as both have the same portion. So each is 1/2 plus 2 plus 1 times 500, and we get 100 grams each. Let's discuss another example. Xavier, Yolanda, and Zita share $8,900 among them. The ratio of Xavier's share to Yolanda's share is 4 to 5. The ratio of Yolanda's share to Zita's share is 6 to 7. How much does each of them get? Here is the solution. Let X, Y, and Z are the shares of Xavier, Yolanda, and Zita respectively. Hence, given the ratio of X to Y is 4 to 5, and the ratio of Y to Z equals 6.7. Notice that Y is the common quantity. Hence, for the first ratio X to Y, we multiply both quantities by 6, and the second ratio Y to Z, we multiply both quantities by 5. So for the first ratio X to Y, we get 24 to 30, and the second ratio, we get 30 to 35. And now we can combine these three quantities together, which we get the ratio of X to Y to Z equals 24 to 30 to 35. And now we can calculate the share for each of them one by one. For Xavier's share, it is equals to 24/24 plus 30 plus 35 times the total amount of money, which is $8,900. And we get $2,400 for Xavier's share. Similarly, for Yolanda's share, it is 30/24 plus 30 plus 35 times 8,900, and we get $3,000. For Zita's share, it is equals to 35/24 plus 30 plus 35 times 8,900, and the answer is $3,500. Let's try this similar example yourself. A mathematics test paper is divided into 3 sections, section A, B, and C. The total marks of the paper is 117. The ratio of the total marks in section A to section B is 2 to 5. The total marks in section A is 3 times the total marks in section C. Find the total marks for each section. You can pause the video and try to find the answer yourself. Alright, here's the solution. Given that the ratio of A to B equals 2 to 5 and the ratio of A to C is 1 to 3 as mentioned in the question, the total marks in section A is 3 times the total marks in section C. Hence, we can notice that the section A is the common quantity. For the second ratio, we can multiply both quantities by 2 and we get the ratio of A to C equals 2 to 6. Now, the quantity A has the same value for both ratio. Hence, we can combine these three quantities into one ratio, which is the ratio of A to B to C equals 2 to 5 to 6. And now, we can calculate the total marks for each section one by one. For section A, it is equals to 2 over 2 plus 5 plus 6 times 117. And it is 18 marks. For section B, it is equals to 5 over 2 plus 5 plus 6 times 117, and it is equals 45 marks. For section C, it is equals to 6 over 2 plus 5 plus 6 times 117, and we get 54 marks. Average rate. Let's look at this scenario. In supermarket A, 10 eggs are sold at the price of $2.20. In supermarket B, 12 eggs are sold at $2.80. Here's the question. Which supermarket sells the cheaper eggs? It is difficult for us to compare in these two scenarios as we have different number of eggs and different prices. So we have to standardize either the price or the number of eggs. Usually, we'll standardize the number of eggs. And now, let's do the calculation. The price of an egg in a supermarket A will be equals $2.20 divided by 10, and we get 22 cents per egg. The price of an egg in supermarket B will be equals $2.80 divided by 12, and we get 23 cents per egg, which is rounded to the nearest 10 cents. And now we can compare the price fairly and make a conclusion that supermarket A sells the cheaper eggs. From this scenario, we can define the rate. Rate involves two quantities and it is usually expressed as one quantity per unit of another quantity. Let's look at another example. 250 ml of ketchup is sold at $3. $400 of ketchup is sold at $4.20. Which one is more worth the price? Here's the solution. The rate of first ketchup, we can calculate it as $3 per 250 ml, and we get $0.012 per ml. The rate of second ketchup equals $4.20 over 400, and it is equals $0.0105 per ml. Or we can calculate the rate at a different way. The rate of the first ketchup equals 250 ml divided by $3, and we get 83 and 1/3 ml per dollar. The rate of first ketchup equals 400 ml over $4.20, and we get 95 and 5/21 ml per dollar. Notice that even though there are two ways we can calculate the rates, but both will give us a conclusion that the second ketchup is cheaper. Now, let's see what's the difference between these two methods. For the first method, the answer tells us each ml what is the cost. Hence, we will choose the lower cost the better. And we can see that the rate of the second ketchup is lower the cost, right, which is $0.0105 per ml. For the second method, we are comparing $1, how much the amount of ketchup we can buy. So if this is the case, we prefer the higher the amount, the better. And we can see that the second ketchup will we can buy more for the second ketchup in $1. Hence, for both methods, it will give us the same conclusion where the second ketchup is more worth the price. Here is a few more real-life examples. 1. The price of 1 unit of 85 square meter private apartment is sold at $1,120,000. Find the price rate of the apartment in dollars per square meter. Here, the price rate will be equals the total amount of the apartment, which is $1,120,000 per the area 85 square meter, and we get $13,176.65 per square meter to the nearest cent. 2. A technician is paid $96 for completing a 3-hour work. A. Find the hourly rate that he charges. The hourly rate that he charged is $96 divided by 3, and it is $32. B. What is his daily earning if he works 8 hours a day? The daily earning will be $32 times 8, which gives us $256. What is his monthly earning if he works 20 days a month? And the monthly earning will be $256 times 20, which gives us $5,120. And what is his annual income? The annual income will be $5,120 times 12 months, and we get $61,440. Speed. What is speed? Speed is the rate of change of distance. In mathematics, speed equals distance over time. Uniform speed. Uniform speed is the speed unchanged over a period of time. It is also known as constant speed. In real life, it is difficult to maintain uniform speed in a motion. Hence, we have average speed, which is more practical to represent a motion over a period of time. The formula of average speed equals total distance over total time. Please remember this formula. Let's see this example. The average speed of a train for the first 3.5 hours of its journey is 70 km per hour. Then it travels at an average speed of 80 km per hour for the next 4.5 hours. Calculate its average speed for the whole journey. Here's the solution. The first thing we need to calculate is the total distance, followed by total time, because the formula of average speed equals total distance over total time. For this example, the total distance will be the speed times the time. So for the first part of the journey is 70 kilometers multiplied with 3.5 hours. And the second part of the journey will be 80 kilometers per hour times 4.5 hours. And the total distance we get is 605 kilometers. The total time will be 3.5 hours plus 4.5 hours, which is 8 hours. And now we can calculate the average speed, which is 605 kilometers per 8 hours. And the answer is 75.6 kilometers per hour to the nearest three significant figures. Now, you can try this similar example yourself. Samuel's house is 4 kilometers away from his school. On a particular day, he cycles to school at an average speed of 15 kilometers per hour. After school, he then cycles back home at an average speed of 18 kilometers per hour. Calculate his average speed for the whole journey. You can pause the video and try to calculate yourself. Here is a solution. The first thing you need to calculate is the total distance followed by total time, as the average speed equals total distance over total time. For this example, the total distance will be equals 4 times 2, as it is 4 kilometers between the house and the school, going to the school and come back from the school, and it is 8 kilometers. To calculate the total time, we know that speed equals distance over time. Hence, time will be distance over speed. Hence, for this example, the first part of the journey will be 4 kilometers over the speed, which is 15 kilometers per hour. And the second part of the journey is 4 kilometers. The speed is 18 kilometers per hour. And it is 22 by 45 hours. And now we can calculate the average speed, which is 8 kilometers over 22 by 45 hours. And the answer is 16.4 kilometers per hour to the nearest three significant figures. Now, let's discuss about conversion of units in speed. We start with the basics. 1 kilometer equals 1000 meters. 1 hour equals 60 minutes. And 1 minute equals 60 seconds. Hence, 1 hour equals 60 times 60, which is 3600 seconds. Conversion from meters per second to kilometers per hour. For example, 30 meters per second. This speed means the motion travels 30 meters every second. To convert to kilometers per hour, first we take the 30 times 60 times 60, which is 108,000 meters per hour, or 108 kilometers per hour. This speed tells us that the motion travels 108 kilometers every hour. In general, to convert from meters per second to kilometers per second per hour, we take the speed in meters per second times 3600 divided by 1000, and it gives us the speed in kilometers per hour. Conversion from kilometers per hour to meters per second, for example, 80 kilometers per hour. This speed tells us that the motion travels 80 kilometers every hour. To convert to meters per second, we change 80 kilometers to 80,000 meters, then divided by 60 times 60, which is 22.2 meters per second, to the nearest three significant figures. This speed tells us that the motion travels 22.2 meters every second. In general, the speed in kilometers per hour times 1000 divided by 3600 gives us the speed in meters per second. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment area. I would love to hear from you. Do you like this video? Please don't forget to like it and share it to your friends. Until then, see you in the next video. Have a great day ahead.